Number 3. In order to determine the operating temperature of an 800 feet length of two-conductor 2-0 solid copper cable, the far ends are connected together, and the resistance is measured from the near end and found to be 0.1575 ohm. The resistance of the cable was similarly measured before installation at a temperature of 23 degrees Celsius and was found to be 0.1278 ohms. The connection between the far ends in each test has negligible resistance. Determine operating temperature of the cable. Okay, so let's start with recalling the formula for your resistance, two different resistances with respect to the temperature coefficient and the temperature of the materials. Okay, so our formula is R2 over R1 is equal to 1 plus the temperature coefficient times the change of temperature, which is your final temperature, minus your initial temperature. Now, we all know that our temperature coefficient is equal to, your temperature coefficient is equal to 1 over the inferred temperature of the material plus your initial temperature. Okay, so this is your initial temperature. If you're going to use the temperature coefficient directly to your formula, your final formula will be look like this. The resistance final over the initial resistance is equal to 1 plus your temperature coefficient with respect to your initial temperature. So that is your temperature coefficient with respect to initial temperature times your final temperature. So what happened to T1? It was eliminated. Look, since it's common both sides, if you substitute, it will be cancelled out. So the remaining is your temperature coefficient at your initial temperature. Now, going back to our problem. So if we evaluate our problem, the resistances are already given. It was found that we have the resistance measured from near end was 0.1575 all over with your initial resistance cables and resistance with the resources. So you have another temperature here. I mean resistance, and at 23 degrees Celsius. So the requirement is determine the temperature operating, the operating temperature of the cable. So that is your final temperature unknown. This is your initial temperature, and this is your final. This is your R2, and this is your R1. Okay, looking back at our formula. Okay, so let's derive our temperature coefficient first. Determine the operating temperature of conductor solid copper. Okay, so for copper, if we recall our inferred temperature, that is 234.5. Okay, so don't forget this is for our copper. So now we can derive our temperature coefficient. This is equal to 1 all over the 234.5 plus your initial temperature, that is 23. This is equal to 0.003883495. So this is your temperature coefficient. Now we're going to use it in our formula. We're going to save this to our memory alpha A. Okay, so doing that, so what is the value of our R2? That is 0.1575 ohms all over your R1. That is 0.1278 ohms equal to 1 plus what is your temperature coefficient, which is equal to your alpha A times your operating temperature. Okay, so finally solving for your T2, that is equal to your T2 is equal to 59.8415493 degrees Celsius. Okay, so that is almost 60. Okay, so that is your operating temperature.